My dear students, we are going to look at combinational logic today from your subject digital logic circuits, which comes under module 4. What we try to do in this lecture is I try to introduce combinational circuits. So in this lecture we are going to look at what exactly combinational circuit, how to identify combinational circuit, what is meant by analysis of a circuit, to be specific combinational circuit. Okay, what is meant by design, how to design combinational circuit, that we will see in next lecture, but we will look at what is meant by design in this lecture. Then we are going to look at how to make analysis of this combinational circuit. If you look at the classification of digital logic circuits, it is of two varieties. The variety 1 is combinational, the variety 2 is sequential. In combinational circuit, there will not be any memory. Output depends only on the present inputs. So output is function of inputs. In sequential circuit, which is of second category of digital logic circuits, there exists a storage elements or memory along with the combinational circuit or logic gates. So the storage content defines the state of the circuit. Wherever there is a memory, there exists a state. Okay, so output are functions of both inputs and the current state of the circuit. State is a function of previous inputs, of course. Output not only in these sequential circuits, output not only depends on present inputs but also depends on past inputs. Okay, this is about classification of digital logic circuits. Next, what we try to do is we are going to look at how a typical combinational circuit look like. So if you see this slide, you can see here there are inputs to the circuit and there are outputs to the circuit. With n number of inputs to the circuit, there is 2 power n possible input combinations possible. Let's suppose if I have 3 inputs, I can give the 3 inputs as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, or before that 1, 1, 0, 1, 1, 1. If I take 4 bits, 2 power 4, 16 possible combinations. If I take anything in general, it is of 2 power n. N can be 1, n can be 2, n can be 3, n can be 4, n can be 5, so on and so forth. Okay. So there are n inputs and there are m outputs, of course. So examples for this is it may be an adder, it may be a subtractor, it may be a comparator, or it may be a decoder, or it may be an encoder, or it can be a multiplexer. So as we proceed in this module, we will be looking at various combinational circuits. Such examples are given over here. What exactly that we do next is we will look at analysis of combinational circuit. Okay. So what is analysis? What is mean by analysis is we know the inputs to the circuit, we know the circuit. By applying input to the circuit, finding the output is known as analysis of combinational circuit. So analysis is to find out the function that is given circuit implements. So what exactly that we try to do is we try to look at the outputs of that particular system given the circuit. What is known is inputs, I know the system. So if you know the system, if you know the inputs, okay, then what we are trying to do, we are trying to find, okay, output. So we are trying to find the output, right? So that is what exactly that is that we are trying to do it. We are trying to find the output. So once you find the output from the input information and system information, here in our system is maybe a complex system or as simple as a simple circuit, say maybe half adder, full adder sort of things. Okay, so we are expected to find Boolean functions, the output function. Of course, you are trying to look at the input output relations, because for every input, what exactly the output that you are getting for every input combination, that I'll try to tabulate input output relations. Okay, so this is what exactly it will do is it is going to give you the possible explanation for what exactly it is going to do. From this input output relation, I can say what circuit is doing. Okay, so firstly, what we try to do is make sure that the given circuit is combinational circuit. Okay, then it's directly straightforward, simple. Apply the input, obtain the output. Okay, so from circuit details or the system details and the input details, if you could able to find the output, then it is called analysis of combinational circuit. Okay, so what is meant by analysis of combinational circuit? We have seen. So what we try to see is we will look at an example circuit. So here is the circuit, here it is AND gate. So try to find what exactly the output here. Let's say T1. Okay, so next find the output at here, find the output T3. Then you combine, you get the output T4. You combine them, all of them together, and try to see what is this. Is it not A dot B dot C AND operation? What about this? It is A plus B plus C. What about this? AB, AC, BC. What you are doing? AB plus BC plus CA. This expression. You can find what is expression T1, what is expression of T2. From T1 and T2 and T3, what is T3? AB plus AC plus BC bar ANDed with A plus B plus C. Okay, which is ORed with what exactly? A, B, C. Okay, so if you look at F2, is it not carry? CARRY, carry. Now if you look at this, okay, ABC plus, okay, AB plus BC plus CA bar into A plus B plus C. If you analyze this will give you sum, or if you make further simplification, we'll get it as sum. Okay, right. So upon this analysis, what exactly we have got is we could able to recognize the combination circuit, be able to do analysis of combination circuit. We can establish the truth table for given circuit. We can understand the requirements of any logic circuit design. Okay, so in the next lecture we will look into the design of logic circuits. Okay.